Hi, my name is Yucheng. I'm the CEO co-founder of ZHub, and I'm here to talk about AI as an engineering discipline. 2023 seemed to have flown by very rapidly with so many things happening all at once. ChatGPT was released early in the year. There were a ton of new AI startups, a ton of new models developed by a lot of different people, different companies, and just generally incredible acceleration development in the field of AI. 2023 was truly the AI epoch. We can now think about cutting the history of AI into two halves, BC and AD. BC is before ChatGPT. And AD, it took a little time to find a phrase that works here. I had to use some help from ChatGPT, but we will call it AI disruption. And of course, here's a ChatGPT generated image of what the AI epoch looks like. And remember, if 2023 was the AI epoch, today's date is 1 AD. And this is going to be a recurring theme here for this talk. Just a quick overview. I have a PhD in machine learning in 2023, specializing in distributed and parallel machine learning, and my specialty was in probabilistic graphical models. Right. I worked at Apple for a little while, scaling the machine learning data storage solution, and had a previous startup that was acquired by Apple in 2016. And currently, I'm the co-founder and CEO at ZHub. With this history, at one point, I would have been called a machine learning expert. But in a couple of years, that has changed very rapidly. Let's look at two different ways to solve a problem, comparing how people might have done it a few years ago versus now. Let's build a model to help people diagnose car problems. To answer this question, really what we're asking for is what's the probability that something failed, some component in the car failed, given that the car does not start. Yesterday, or perhaps before the rise of AI, what we might have used would have been the probabilistic graphical models. To build one of these well, we have required a depth of statistical methods, ranging from conditional distributions, parameter learning, structured learning, causal inference, Markov chain Monte Carlo, and so on. But today, we can just try out to ask this question to ChatGPT. You are diagnosing a car failure. The car does not start. Please provide a ranked list of issues to investigate, as well as estimate the probabilities of each issue being the root cause. And I get a list with probabilities. Dead battery, starter motor, fuel problems, each with a probability. Say I evaluate the top issue, that the battery is dead, and we check the car and find that there are no problems. I just asked ChatGPT to give me an updated list saying that all electrical systems are fine. Please give me an updated list of issues. And I get an updated list of issues without electrical problems, where the highest probability is fuel problems. Now, something amazing just happened. I just did conditional probabilities without actually knowing anything about conditional distributions. Now, is this actually calibrated and mathematically sound? Who knows? But does it truly matter if it is useful? What has changed is that many things that would have required a PhD in statistics to do well now can be easily done by anyone. And finally, AI ML is truly accessible to anyone. So what really has happened is that AI has shifted from a scientific discipline of experiments to an engineering discipline, where we are now primarily concerned with engineering principles, product delivery, and so on. I do dislike the word democratize, but really this is the engineerization of AI. And what is the difference between scientists and engineers? Engineers like to build. And so in only a short couple of years, we have thousands of startup building tools for ML. It's difficult to find exact numbers, but we can ask ChatGPT. How many AI ML big data startups are there in 2016? It says about 550, and in 2023, it says about 4,643. Now, I do somewhat believe this number because in my previous startup around 2013 or so, I felt like I knew every startup in the machine learning space. But today, it has become impossible to follow. For instance, here's a list of startup logos I found. This is a list from Israel, Sweden, USA, UK, and of course this is unlikely to even barely be complete in any way. We'll zoom in on one of these lists because my company is on it. We are there under versioning and experiment tracking. But really, stepping back, the key question is, with the proliferation of all these tools, it raises the question of what do we use? Which foundation model? Anthropic, OpenAI, Llama, which embeddings, which vector database, and many, many other questions. But these are the wrong questions to ask. I'm not going to tell you what to use. If you come to this talk expecting me to help cut through the noise of tools, sorry, you'll be disappointed. Instead, I want to communicate some principles you should be thinking about when building AI applications. But before that, let's look at some basic trends. This is the graph of the state of the art on MMLU, which is a language understanding benchmarks. We can see that the best models are increasingly massive to about 2 trillion, nearly 2 trillion parameters today. But we do also see that smaller models are being developed that are competitive with bigger models. Mistral 7B will roughly be equivalent about 280 billion parameters just about a couple of years ago. Llama 3 with 8 billion parameters, it's about equivalent to about 70 odd billion parameters for about a year ago. And Llama 70B will probably be about equivalent to about 1 trillion parameters for about a year ago as well. So parameter efficiency has increased massively. And yet, hot off the press, Phi 3 is claimed to have over 2x parameter efficiency over Llama 3. Now, this is not scientific, and we are just eyeballing here. Perhaps a scientific study would be nice. But just generally, parameter efficiency has been increasing. So, the reality is that the best models will probably keep getting bigger. But the useful models will get smaller. And all models will get faster. And this is a general pattern that has repeated over and over again historically throughout the history of computer science, from set solvers to many, many other domains. Now, I'm also going to say something massively controversial here, and I'm going to dump on a lot of research and industry work. A lot of tools today exist simply to address limitations of today's models. RAG, or Retrieval Augmented Generation, a very popular method today, I believe is only a temporary solution, and is used to address the problems that current models have very small context. Fine-tuning is very expensive, and the reality is that LLMs today can't use tools that well. They are not able to leverage other tools to search and retrieve information. And also, you do not need a vector database. Google that. This is a blog post I wrote a little while back. Agents are also just temporary solutions to today's models. It's because today's current models can't plan well, and really, it is a very crude method to achieve what is essentially an ensemble model. Now, future solutions will be completely different and will likely be very, very different as today's models keep improving. Once again, remember that we are only in 180. So how do we cope with this? How do we even think about building the right AI architecture for your company and your organization? What is the right software architecture for AI? We attack it just like any other engineering problem. First, have clear objectives. Are we talking about accuracy, precision, recall, or maybe something like k-shot retrieval? No. The objective, the questions to ask are, why do you want AI in your product? What does it improve? And how do I measure that improvement? What is the business metric that you actually care about improving? If you can't measure it, you can't improve it. Are you trying to improve time savings, user engagement, click-through rate? Know what you really want and how you are going to measure it. Actually perform engineering. Know the parameters of the bridge you are building and what it is meant for. Is it meant for rails? Is it meant for cars or something else? Let's take a concrete example. Remember the question about which model to use? We begin by thinking about what are the requirements. What are the product requirements with regards to cost, latency, query per second, memory? Is there internet access? What happens if the model query fails? Is there compute power available? And remember that there's no consistent way to compare model performance. Bigger is not always better, and newer is not always better. Think about what is the accuracy needs that meets your objectives. And start with the smallest model and cheapest model you have, and work your way up. Principle 2 is that the AI can be wrong. This may be very obvious to a lot of AI/ML practitioners, but what is less obvious is how this affects product design. And this is a lesson I took a lot from Apple. Say I build a website, superaidoctor.com, that allows a doctor to upload an X-ray image and returns a classification. Now, you may have inadvertently positioned your model as a confident expert. A person unfamiliar with the limitations of AI will completely misinterpret the results. Know what happens when the AI gives a wrong answer. Do not design UX which allows people to believe the AI is an expert. Consider how the output is presented and how it is meant to be used and consumed. And the principle 3 is that software engineering practices still apply. Say today I'm using all my software engineering best practices. I'm using code reviews on GitHub. I am using, say, CircleCI, just throwing some tools out there, CircleCI for continuous integration and testing, and I'm using Artifactory for reproducible artifacts. And your manager comes in and says, let's do AI. What does that change? Nothing. Everything here is still important. Nothing ever changes. Nothing changed. The only difference is that you have to now find a way to deal with this massive brick called data that infects everything you do. That this brick can be 1,000,000 times bigger in size and volume than all the rest of your code base combined. But no big deal otherwise. And here I'll give a quick shout out to my startup, and this is really how Setup came about, with the goals of trying to scale all these processes to be able to deal with that brick. And really, all this means is that data is a dependency just like code. And this is a very big takeaway from this slide, and this is perhaps the one sentence TLDR that is really classic paper from 2015 from Google, and I do highly recommend people read that. It's fine to hack up solutions to be a proof of concepts, but for production use, your tools should always enable you to have reproducibility. Just like software engineering, you should be able to go back in time to be able to recreate any artifact. Right? Predictions, models, embeddings made things deterministic. Testability, just like code, you need to be able to test your code. You need to test perform unit tests, perform integration tests, end-to-end tests, and just like code, have the ability to collaborate. Right? Have clear process for knowledge transfer and sharing. How do you document code and data and processes? Now, all these are going to be vary from organization to organization. And the key thing now is, once again, you need a way to deal with this brick called data. How do we deal with reproducibility when you have a lot of data involved? How do you deal with testability when you have this brick involved? How do you deal with collaboration? Think about processes you need and the tools applicable, and pick ones that make sense for your needs. The final advice is to reduce complexity. We look to one of our great leading minds in software development called Grug, and he says, given choice between complexity or one-on-one against T-Rex, Grug takes T-Rex. At least Grug sees T-Rex. Expect change. Minimize complexity. Really, the solution you build today is likely to be wrong or deprecated in a couple of years. Look for the simplest solution that works for you with the lowest maintenance and system overhead and the easiest to swap in and out. Don't get locked in. with a breadth of choice of tools today, perhaps now backend engineers will sympathize with front-end engineers because we have to deal with frameworks and tools changing year after year. In summary, have clear objectives. Your design must assume that the AI can be wrong. Apply software engineering best practices and reduce complexity. But really, few of these are AI specific and really are just reiterations of standard engineering and product principles. But the key takeaway here is that these engineering principles must be applied in a world of constant change. If there's one takeaway from this talk, today's date is 180. AI methods today may not be there tomorrow, but good engineering practices are forever. Thank you.